I'm going to prove a bunch of facts about integrals, and I will assume that g and f are integral on a, b, and the integral of f plus g equals the integral of f plus integral of g. And I'm suppressing the a's and the b's to save me a lot of time writing. So if you ever see an integral sign, it's the integral from a to b on here. So here's a proof of one, the only one that I read. You can look through these. And these proofs are largely just kind of follow your nose. So what I'm going to do is I'm going to start with the integral of f plus g. Well, that's defined to be u of f plus g, which is defined to be the infimum of the set of u of f plus g comma p's, where p is any partition of AB. Well, we can figure out the definition of the u things, so that we're just looking at the infimum of these are the sums of mi times xi minus 1, where these sums, the i's depend on what partition. But I can actually do this a little bit better than that, because this m is really just going to be the supremum of all the f's and g's are going to be the supremum of f and the supremum of g. So what I can do is I can rewrite that m as, say, I plus mi prime, where this one goes with f, that's the supremum of f, and this one is going to go with g, that's the supremum of g, and I need to write, this should be a definite prime, times xi minus 1. Because that's what the supremum of f plus g is going to be. It's going to be, you add the two suprema. Okay, oh, well, look at this. I can just kind of write this out. Just using some algebra here, I'm going to get the infimum of mi times xi minus 1 plus the supremum, or the sum of mi prime, the stuff with the g's. Right, I'm just distributing and then regrouping, because these are just finite sums. Oh, well, if I have the infimum of kind of a set A, all the elements of a set A, and all the elements of a set B, that's just going to be the infimum of the sum of the mi, xi minus 1, over the partitions, plus the infimum of the second. This is back to chapter 1 stuff. So I'm doing nothing tricky here. I'm just going back and using what we know about suprema. Xi minus 1 over the partitions. Oh, but this is defined to be the infimum of, well, these are just u of f of p. And these are just the infimum, that's just the infimum of all the u of g of p. Oh, well, that's just equal to u of f plus u of g. Oh, but as long as these are integrable, that's equal to the integral of f, and that's equal to the integral of g. So we proved number 1, integral of f plus g equals integral f plus integral g. Very, very similarly, we can prove the second one. So proof 2 is going to be kf. It's going to be equal to the u of kf, which equals the u of the kfp, which is going to equal to the infimum stuff, so I'll just skip straight to there in the interest of time. It's going to be equal to, well, if you do a little bit of thinking about this, the supremum of kf is just going to be k times the supremum of f for any interval. I minus xi minus 1 over all partitions. Oh, but what I can do is I can factor out a k out of here, and that basically, again, using chapter 1 properties, that gives us k times the infimum of the sum of the m times the intervals over p. This is x minus x. And that's just k times the infimum of the u of f of p's, which equals k times the integral. Because, yeah, like so, we're done.